Hello dear students, I hope you are doing well. I welcome you to the third part of S block elements. In this video, we are going to start with the group 2 elements. So group 2 elements are beryllium, magnesium, calcium, strontium, barium and radium. So you know how to write the atomic number? Beryllium is 4. Magnesium will be 4 plus 8, 12. Calcium will be 12 plus 8, 20. Strontium will be 20 plus 18, 38. Barium will be 38 plus 18, that is 56. Radium will be 56 plus 32, that is 88. So first, let us see how to write the electronic configuration. Beryllium, atomic number 4, that means there are 4 electrons. So electronic configuration 1s2, 2s2. If you use the inert gas, for beryllium, the nearest inert gas is helium. Helium, that is 1s2, 2s2. Similarly, for magnesium with atomic number 12, the nearest inert gas is neon. So neon, 3s2. Calcium, 20, nearest inert gas will be argon, 4s2. Strontium, atomic number 38, nearest inert gas will be krypton, 5s2. Barium, nearest inert gas is xenon, 6s2. Radium, the nearest inert gas is radon, 7s2. So this is how we write the electronic configuration using inert gas. Next, let us see the atomic and ionic radii of group 2 elements. So again, we have to take the help of the electronic configuration. Beryllium atomic number is 4, so is helium, 2s2. Magnesium is 12, so is neon, 3s2. Calcium is 20, so is argon, 4s2. Strontium is 38, so is krypton, 5s2. Barium is 56, xenon, 6s2. Radium is 88, radon, 7s2. So you can see here, as we go down from beryllium to radium, the number of cell increases, 2, 3, 4, 5, 6, 7. So if beryllium has 2 cells, in the inner cell will have 2 electrons, outer cell also will have 2 electrons. For magnesium, there will be 3 cells, 1, 2, 3. For calcium, there will be 4 cells, 1, 2, 3, 4. Now we already know atomic radii is the distance between the center, that is nucleus, to the outermost cell. Now if you compare beryllium, atomic radii is this. For magnesium, this is the atomic radii. For calcium, this is the atomic radii. So if you compare beryllium, magnesium and calcium, you can see the atomic radii increases. Now it's very simple. It increases due to increase in the number of electronic cells. So similarly, if you compare from beryllium to radium, the atomic radii increases. The atomic radii increases due to increase in number of electronic cells. 'cells. Simple, due to increase in number of electronic cells. What about the ionic radii? If we check the group 2 elements, they form divalent ion. Say if we take magnesium, atomic number is 12. So the nearest inert gas to magnesium is neon. So if they have to attain the electronic configuration of neon, they need to lose 2 electrons. So if they lose 2 electrons, they will get 2 positive charge. So if we compare the atomic radii and ionic radii of group 2, the atomic radii is always longer than the ionic radii. Similarly, the atomic radii of beryllium is longer than the atomic radii of beryllium. Atomic radii of calcium is longer than the ionic radii of calcium. However, for the ionic radii, say Be2 positive, Mg2 positive, Ca2 positive, then after this strontium 2 positive, barium 2 positive, radium 2 positive. As we go down, again the ionic radii increases. Ionic radii increases. This is simply because of the increase in number of electronic cells. The concept remains same for atomic radii and ionic radii if you go down the group, but if you compare atomic radii with ionic radii, atomic radii of group 2 elements will have will be longer. Next, let us study the ionization enthalpy, or we can say ionization potential. So we already know ionization enthalpy is the energy required to remove an electron from the outermost cell. So beryllium, magnesium, calcium, strontium, barium and radium. Now we know as we go down, the size increases. Now we know if the size increases, nuclear charge decreases, and if nuclear charge decreases, ionization enthalpy also decreases. So the concept is same with the group 1 element. For group 1 element also, when the size decreases, ionization enthalpy decreases due to decrease in the nuclear charge. For group 2 also it's same. As we go down, size increases. Why the size increases? We already know it. It increases due to increase in number of electronic cells. So if the size increases, nuclear charge decreases because the valence electron will move far away from the nucleus. And if the nuclear charge decreases, ionization enthalpy decreases. Now if we compare the elements of group 1 and group 2, so if you compare sodium with magnesium, the ionization enthalpy of magnesium will be more than sodium. This is due to the decrease in size across the period. However, the second ionization enthalpy, remember there are first ionization enthalpy, second ionization enthalpy, third ionization enthalpy. Now what is this first, second and third? If you are removing the first electron, the energy required is known as first ionization enthalpy. If you are removing the second electron, that means you have already removed one. You are going for the second one. The energy required is known as second ionization enthalpy. If you are removing the third electron, that means you have already removed two. The energy required is known as third ionization enthalpy. So the first ionization enthalpy of sodium is less than the first ionization enthalpy of magnesium. But when we check the second ionization enthalpy of sodium, it's more than the second ionization enthalpy of magnesium. This is due to the stable electronic configuration. Sodium, after losing one electron, it will have the inert gas configuration of neon. So it's more stable than the electronic configuration of magnesium in +1 state. That's why the ionization enthalpy of sodium, that is second ionization enthalpy, is more than the second ionization enthalpy of magnesium. Next, physical properties. Density. So alkaline earth metal, that is group 2 elements also, that have low density. However, the density, it increases down the group. Then melting point and boiling point. Alkaline earth metal also have low melting point and boiling point. This is due to weak metallic bonding. However, the melting point and boiling point of group 2 elements, that is elements like beryllium, magnesium, calcium, is more than the melting point and boiling point of group 1 elements like sodium, potassium, etc. Next, let us see the chemical properties. Chemical properties of group 2 elements. So first, let us see the reaction. Reaction with air. Beryllium and magnesium, they are kinetically inert. Now, kinetically inert means they are less reactive toward air and water. However, under favorable condition, these elements react with air to form their respective oxides. Like beryllium will form beryllium oxide, oxide form magnesium, Mg plus O2 will form magnesium oxide. Then calcium with oxygen forms calcium oxide. Next, reaction with water. Same with water, beryllium and magnesium, they are kinetically inert. They don't easily react with air and water. However, they react under favorable condition. Whereas rest of the elements, they easily react with water to form hydroxide, its respective hydroxide and hydrogen gas. Say if calcium reacts with water, it will form calcium hydroxide, that is CaOH2 and hydrogen gas. If magnesium, under favorable condition, if it reacts with water, it will form magnesium hydroxide and hydrogen gas. Next, let us see the reaction of group 2 elements with dihydrogen. So group 2 elements also reacts with dihydrogen H2 to form hydrides, that is metal hydrides. Say for example, if calcium reacts with dihydrogen, it forms CaH2. If magnesium reacts with H2, forms MgH2. Next, reaction with halogen. So alkaline earth metal, they react with halogen to form metal halide of the formula MX2. Say for example, if magnesium reacts with chlorine, it forms magnesium chloride. If calcium reacts with chlorine, it forms calcium chloride. Next, let us study a very important topic which is known as diagonal relationship. Now, what is this diagonal relationship? Lithium, first group, sodium, also first group. Second group we have beryllium and magnesium. Third group we have boron and aluminum, and so on. Now it's found that the properties of lithium and magnesium, they are similar. Properties of beryllium and aluminum, they are similar. And how are they related? They are placed diagonally. So this relationship between lithium and magnesium, beryllium and aluminum is known as diagonal relationship. Now if you want to know why they have similar properties, we know as we go down, size increases. But along the period, size decreases. So you'll say the size of lithium is somehow similar to the size of magnesium. Size of beryllium is somehow similar to the size of aluminum. Now, since they have similar size, the properties also will be similar. That's why the properties of lithium and magnesium, they are similar. Properties of beryllium and aluminum, they are similar. So this relationship is diagonal relationship. So this is your S block elements. In the next video, we'll start a new chapter. Till then, stay safe, stay home. Thank you.